Maths channel. And this question that I'm answering here is a question from an IGCSE paper. It's from the winter, October, November 2013 IGCSE Cambridge from the 0580 syllabus. This is paper 2, variant 1. And this question is here about scale models. So it's to do with similarity and scales. Now here we're told that the volume of a child's model plane is 1,200 centimeters cubed, and the volume of the full-size plane is 4,050 meters cubed. Find the scale of the model in the form 1 to n. Now one of the things that we have to realize is that the scale, when they mention the scale of a model or a map, they mean the scale in terms of the ratio of the lengths, okay, not the ratio of, for example, here the volumes. This is what they gave us is the volume of the child's model and the volume of the full-size model. Okay, so from that we can find the ratio of the volumes, but in the end we want to find the ratio of the lengths in the form 1 to n. And of course the model is going to be smaller than the real thing. Okay, so you're going to have the model. One second, let me just get the pen sorted out. You're going to get the model to the real thing, okay, to the actual plane. Okay, I can put model to full size maybe. Okay, so the model, its volume is 1,200 centimeters cubed, and the full size plane is 4,050 meters cubed. So now we see that the units are not the same. So one of the things that we should try to do is to make the units the same first, and then we can deal with simplifying the ratio, and then we'll end up with having things in terms of changing them in terms of ratio of volumes to ratio of lengths. Right now this is a ratio of volumes, but the units are different. So I'm going to change the meters cubed into centimeters cubed because I think that will be maybe a bit easier. Okay, so what we should realize is when we're changing from meters to centimeters, we're going from larger to smaller, and we have to multiply by how many centimeters are in a meter, which is 100. However, when we're going from meters cubed to centimeters cubed, you must cube that conversion. Okay, so 4,050 meters cubed has to be multiplied by 100 cubed to give us the same number in centimeters cubed. So we have 1,200 centimeters cubed, and this is to 4,050 times, I'll write it like this, 100 cubed centimeters cubed. Now we have the same unit, so I can get rid of the units. With the scale, there's no unit, so you have to make sure when you write that in this form, there's no unit. So now we've expressed them as the same unit, we can get rid of the units. So now what I can do is I can say the scale in terms of the volume is 4,050 times 100 cubed divided by 1,200. Okay, now that's the ratio of the volumes. That's a volume ratio. Okay, we want the length ratio. Our scale that we want is the length ratio, and the length ratio is going to be, if you want to go from volume to length, you have to take the cube root. So we're going to take the cube root. The cube root of 1 is going to be 1 anyway. So the cube root of all of this, 4,050 times 100 cubed over 1,200, that will give us our answer. Okay, that will give us our answer in terms of 1 to n. So if we take that and we do the cube root of, I could have used that button, but no problem. I've got a fraction, I've got 4,050 multiplied by 100 cubed divided by 1,200. That gives me 150. So it's 1 to 150. That's the scale of this model. Okay, so a few very important points here is that one, when they ask for the scale of the model, they don't mention anything in terms of, you know, the scale in terms of length, volume, or area. By default, it means the length. Okay, so this is a ratio of the lengths that they want. The ratio of the lengths for the model to the real thing. That's what they want, and that's what we found in the end. Okay, so they gave us the volume of the model plane and they gave us the volume of the full-size plane. Okay, and the first thing we did is we changed them into the same unit. So I changed from centimeters cubed to, from meters cubed to centimeters cubed by multiplying by 100 cubed, because there's 100 centimeters in a meter. So therefore there's 100 cubed centimeters cubed in a meters cubed. Okay, so that's very important for us to realize. When we're changing units of volume, we cube the normal conversion. When we're changing units of area, we square the normal conversion. And I have a video which I will link at the end, or on one of the cards you should see appearing up here, which explains to you exactly why we square and cube. It's another question similar to this one, and I've explained that in some more detail there, so I'll link that at the top during this. You'll see that a card appearing during this video. Okay, and then once we have converted the units to the units of centimeters cubed, so now they're the same unit, we cancel out the units because now they're the same unit. A ratio shouldn't have any units in there. Okay, and then what we have now is the ratio of the volumes of the model to the real full-size plane, and we want the ratio of the lengths. So we take the ratio of the volumes and we cube root that. So the cube root of 1 is going to be 1 anyway, and the cube root of all of this gives us 150, and that's our answer. So 1 to 150. So that answers that question. I hope that was clear. Other questions from this particular paper, when I get to answer them, will be found in the playlist that will appear in this region over here. Other questions from this topic of similarity. Okay, this is to do with similarity. I'll put in the playlist over here. Other questions to do with scale models. Okay, just, basically ratios and scales will be in this playlist over here. And you can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.